All right, so today we're looking at solving systems of equations by graphing. First off, we need to discuss what exactly is a system of linear equations. Well, very simply, it's two or more. Most of ours are going to be two, but we will see some with three related equations. All right, and what is the solution to a system of equations? Because we don't care about a system if we don't have a solution. And the solution is specifically a point. An actual point. It will have coordinates x, y that satisfies both, or all three or all four if we have more than one, equations. All right, so what do we mean by satisfies? All right, very simply, we mean that if we take this point, our xy point, and I plug in the x into both of my equations, and I plug in the y into both of my equations, that I will end up with a true result for both of those. So this point is true for both equations. All right, so let's look at our first method of solving a system of equations, which is graphing. In order to solve by graphing, we're going to put both equations on the same graph, and we're going to look at where they cross. All right, so first one here, y equals negative x plus 2. So let's graph this. In fact, I'm going to rewrite these down here so we can see. All right. Rewriting this down here so when I scroll we can see the equations. All right, so y equals negative x plus 2. So we start at our y-intercept, which is where x equals 0 and y equals 2. Right here, we use our slope, which is negative 1, which means I'm going to go down 1 and right 1, down 1 and right 1, down 1 and right 1, and so on and so forth. We can then draw our line. Let me actually get me some more dots going up this direction. All right. Next, we're going to grab our second equation. Let me grab a different color here. Grab green. I'm going to graph this one. All right, this says y equals 2x plus 5. So we start once again with our y-intercept, which is where x is 0 and y equals 5. So 1, 2, 3, 4, 5. My slope here is 2, which means I'm going to go up 2 and right 1, up 2 and right 1. Go back to my y-intercept. I can go down 2 and left 1, down 2 and left 1, down 2 and left 1, and so on. All right, and then I can draw my line. All right, so what we're looking for with our solution is we're looking for the point where the two lines intersect. Where do they cross? Well, very obviously they cross right here, right? So what is that point? What's the coordinates of that point? Well, x first, negative 1, y coordinate 1, 2, 3. So my solution is negative 1, 3. All right, so my solution to a system of equations is always going to be a point. You should always, always, always give me an ordered pair like this. I need to see the coordinates. I don't care if it ends up on the x-axis or the y-axis. Don't ever give me just a single number. I need to see the coordinates. All right, let's move on to example B. First one, y equals 5x plus 2. And y equals 3x. All right, let's scroll down so we can see our graph. Starting with the first one, start with our y-intercept, which is 2. Our slope is 5, so that means I'm going to go up 5. 1, 2, 3, 4, 5, and over 1. And I'm going to go back here and I'm going to go down 5. 1, 2, 3, 4, 5, and to the left one. And we're going to draw our line. All right, next we're going to look at y equals 3x. We don't have a y-intercept listed. Remember, we don't have it listed. It's the same thing as saying plus 0, which means that our y-intercept is actually going to be at the origin. And this one, our slope is 3, which means I'm going to go up 3, 1, 2, 3, and to the right one. I'm going to go up 3, 1, 2, 3, and to the right one. Then for my slope, from my y-intercept, I can go down 3, 1, 2, 3, and to the left one. Down 3, 1, 2, 3, and to the left one. Down 3, 1, 2, 3, and to the left one. All right. And then we draw our line. Now, ideally, we should be using a ruler here so that we get nice straight lines. But did you notice when I was making my dots, I literally made this dot directly on top of one of the dots for my blue line. So this right here is going to be where they intersect. This is going to be my solution. So what is the coordinates of that point? Well, my x coordinate is -1. My y coordinate is -3. So this point is at -1, -3. A word of caution here. Do you notice how the solution to the one we just did, looks very similar to the solution to the one we did before? The only difference, the negative sign on that 3. These 2 points are not in the same position on this graph at all. Make sure you are paying very close attention to your negative signs when you're giving me solutions, because it does not mean the same thing at all, and you will not be getting the points or getting it correct if you omitted a negative sign or added one where it did not belong. All right, let's flip our page over. We're going to graph some more. Oh, we have standard form. How do we graph from standard form? All right, well, you have a couple of choices. Choice number 1 is we can convert it to slope-intercept form, right? So let's do that with example C. 3x minus 2y equals 12. I want to subtract 3x from both sides because my goal here is to get y by itself. So negative 2y equals negative 3x plus 12. Divide both sides by -2. So y equals positive 3/2 because -3 divided by +2. Sorry, -3 divided by -2 gives me a positive. So positive 3/2 x minus 6. So that's my first one. Let's go ahead and graph that guy while I've got the blue pen out. So I start at my y-intercept, which is -6. 1, 2, 3, 4, 5, 6. And then I use my slope, up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. I could just go down 3 and left 2. And then I draw my line. All right, let's go back up here. Let's grab my green pen and let's do the other one into slope-intercept form. So 6x minus 4y equals 12. Subtract 6x from both sides. So negative 4y equals negative 6x plus 12. I'm going to add, I'm not going to add 4y. We're going to divide both sides by -4. So y equals, well, a positive 6/4, which is really 3/2, x minus 3. Anybody else seeing what I'm seeing? Let's graph it and see if you're right. All right, so start at my y-intercept, which is -3. I'm going to use my slope, up 3, right 2, up 3, right 2, up 3, right 2, up 3, right 2. Go back here, I can go down 3, left 2, down 3, left 2. Do y'all notice anything? They don't intersect. Are they ever going to intersect? No. If you're being observant, you will notice that both of these equations have the same slope. What do we call two lines that have the same slope? They're parallel. All right, and parallel lines never intersect. So the solution here is no solution. And if you even want to include the detail that is parallel, that is perfectly all right. All right, so let's go to example D, and I'm going to show you the other option we have when we're talking about graphing from standard form. So the first option was convert it to slope-intercept form. The other option when we're starting with standard form is to find the x and y intercepts and then graph it. All right, so number one, we have 2x plus 5y equals 10. All right, so we want to find the x-intercept. In order to find the x-intercept, we put our finger over the y and we solve for x. Doing that, covering up the y, gives me 2x equals 10. So 2x equals 10. Divide both sides by 2. So x equals 5. So my x-intercept is where x equals 5 and y equals 0. All right, going back, get us some space here. And then let's solve for our y-intercept. So for our y-intercept, we're going to cover up the x and solve for y. Covering up the x gives me 5y equals 10. So 5y equals 10. Divide both sides by 5. Then y equals 2. So my y-intercept is where x equals 0 and y equals 2. One moment.
Mr. Reeves and Mr. Matthews, please stop by the main office. Mr. Reeves and Mr. Matthews, please stop by the main office. Thank you.
I don't know if you could hear that announcement, but that was Mr. Lowry over the intercom. All right, back to math. So grab our blue line here, and we're going to graph this. So my x-intercept is where x equals 5 and y equals 0. 1, 2, 3, 4, 5. My y-intercept is where x equals 0 and y equals 2. So right here. All right, having 2 points now, we can actually make a line. I'm actually going to use the nice fancy line tool I've got here. And we're going to go from here to here. Hang on, undo. I actually want a line. You give me a line. There we go. And now my line goes through both my points. All right, next, going back, we're going to find the x and y intercepts of our other equation. Grab my green pen, which is 4x plus 10y equals 20. All right, do our x-intercept first. So we cover up the y, gives me 4x equals 20. So 4x equals 20. Divide both sides by 4. I get x equals 5. So my x-intercept is where x equals 5 and y equals 0. All right, next we're going to do my y-intercept. For my y-intercept, I'm going to cover up the x and solve for y. So that gives me 10y equals 20. Divide both sides by 10. So I get y equals 2. So my y-intercept is where x equals 0 and y equals 2. Anybody noticing anything here? Get out my green pen. My x-intercept is 5, 0. My y-intercept is 0, 2. My x-intercepts and my y-intercepts are the same. These are literally the same line. So what's our solution going to be if I just drew one line on top of the other? It's going to be infinite solutions. All right, because there are infinitely many. That line goes on and on forever in both directions. So we're going to say infinite solutions. I-N-F-I-N-I-T-E. There we go. Now be very careful here, because it is very tempting to write down all real numbers as the solution for this, but all real numbers is not accurate. Because, for example, this point right here is a real number. That's not on my line. That is definitely not a solution. Okay, so we have an infinite number of answers for this, but all real numbers are not answers for this. All right, so far we've seen two special cases. We know parallel lines have no solution. The same lines have infinite solutions. All right, we have two more examples, but you all have learned how to graph both from slope-intercept form and standard form. So you are ready to do your homework. I don't think I'll do the last two examples and waste your time with those. As always, if you have any questions, send me an email and I'll be happy to answer them. Good luck on your homework.